There is a specific phrase in NOAA's active region terminology that scientists reserve for sunspot groups carrying the highest potential for significant solar flares. Not high potential, not elevated risk, but the highest possible classification in the system, beta delta. A configuration where opposite magnetic polarity regions are so intermingled, so close, so energetically strained against each other that the release of stored magnetic energy through reconnection is not a remote possibility. It is a question of when, not if. Active region AR 4494 has been classified beta delta for days. It is classified beta delta right now, and it is classified beta delta at a moment when 4 additional active regions are simultaneously present on the Earth-facing solar disk, giving scientists watching the sun's current state something that is worth pausing to appreciate in its full context. Solar cycle 25 peaked in October 2024. The 365-day smoothed sunspot number reached its maximum on October 11th and 12th, 2024, and solar activity officially entered its declining phase by February 2026, when a strong decrease in the number of sunspots was recorded. By the standard metrics of solar cycle analysis, July 2026 should be a quieter month than October 2024 or November 2023, or any of the months surrounding the cycle's maximum. The declining phase is supposed to look different from the maximum. Less complex active regions, fewer M and X class flares, quieter geomagnetic conditions. Despite the overall decline, the Earth-facing solar disk currently hosts multiple sunspot regions with significant magnetic complexity. Active region AR 4494 retains its beta delta classification, the most energetically complex configuration, and continued to show flux emergence as of July 26th. AR 4496, a newer region in the northeast quadrant, is growing and has many days of geoeffective potential ahead. July 2026 does not look like the declining phase. It looks like something that solar physicists studying the historical record of solar cycles call a transient secondary burst, a period within the post-maximum decline where a concentration of unusually active regions on the disk simultaneously produces activity levels approaching or equaling the maximum period. These bursts are documented in the records of previous solar cycles. They are not anomalies that break the cycle model. They are irregular features within the declining phase that emerge when the solar dynamo, even in its post-peak state, produces a cluster of highly complex active regions in rapid succession. July 2026's burst began with the machine gun sun of early July, when active region AR 4479 produced the X1.1 full halo CME on June 30th, and then continued firing through the first week of July with 10 solar flares in a single 24-hour period. It continued through the 3 CME sequence of late July that this channel covered when NOAA issued G1 to G2 storm watches for July 24th and 25th. And it accelerated into its most complex and energetic phase on July 27th and 28th, when the solar disk produced something that is genuinely unusual enough that scientists are still analyzing it. 2 synchronized eruptions firing at exactly the same moment from different parts of the solar disk. The sun returned to a low flare level over the past day, producing C-class flares only, but our star still surprised us by blasting out 2 synchronized eruptions. The first started at around 6 o'clock UTC on July 27th. It was a huge filament eruption hurling tons of plasma into space. The event was centered over the sun's central meridian, or midline, just north of where it meets the solar equator. Remarkably, as this filament eruption began, a huge prominence appeared on the sun's northwest horizon that signaled a similar event on the far side. 2 eruptions, same moment, different locations on the solar disk. One on the Earth-facing side, centered near the central meridian, a massive filament eruption visible directly in SDO imagery, hurling tons of plasma outward. And simultaneously, at the same timestamp as the filament eruption began, a huge prominence appearing on the sun's northwest horizon. Prominences are visible on the solar limb when they extend above the edge of the solar disk. A prominence appearing at the northwest horizon at the same moment as a central meridian filament eruption means exactly one thing. Something was erupting on the far side of the sun, and the prominence was the far side eruption's material rising above the solar limb into the line of sight. 2 simultaneous eruptions, 2 completely different locations, one on the Earth-facing hemisphere, one on the far side, triggered at the same moment. The physical mechanism by which 2 eruptions in different solar locations can trigger each other, or by which a single deeper solar process can drive simultaneous surface eruptions at multiple locations, is actively studied in solar physics, but is not completely understood. Solar sympathetic eruptions, as they are called in literature, have been documented before. What made the July 27th event notable to the scientists watching it was the simultaneous nature and the scale of both events. A huge filament eruption combined with a huge far side prominence, both major eruptions occurring within the same UTC timestamp. The Earth Sky team, which provides daily real-time solar monitoring updates, specifically flagged this event as unusual. Our star still surprised us. In the language of a team that covers solar activity every single day, surprised us is precise phrasing. Not unexpected, not elevated, surprised. The team that watches the sun for a living, writing to an audience that follows the sun for interest, using the word surprised. The CMEs produced by the July 27th and 28th eruptions are what NOAA modeled as the cannibal CME scenario, a faster ejection overtaking a slower one in transit. And they delivered their impact at Earth on July 29th. The critical consequence of this merging is not just amplified energy, it is unpredictability. The merged structure's internal magnetic field orientation is less stable and harder to model, meaning the BZ component's behavior becomes harder to predict in advance. The BZ component, the north-south orientation of the interplanetary magnetic field carried by the arriving CME plasma cloud, is the single measurement taken by the DSCOVR satellite at the L1 Lagrange point approximately 15 to 60 minutes before the CME impact reaches Earth that determines whether a forecasted G2 storm delivers exactly what models predicted or whether it falls short or exceeds expectations. The cannibal CME's merged structure carries a magnetic field that is the combination of two separate ejections' magnetic fields interacting and evolving during transit. The result is less predictable than a single CME's field because there is no single source eruption to characterize its magnetic topology from. When the cannibal CME arrived at DSCOVR on July 29th, the real-time solar wind data showed the expected shock front, the sudden jump in solar wind speed and magnetic field strength that marks a CME's leading edge passing through the L1 point. The BZ measurement in the minutes after the shock determined how the magnetosphere coupled with the arriving plasma. Geomagnetic storm conditions developed as the storm's main phase progressed through July 29th. The KP index climbed. Aurora was visible across Canada, Alaska, Scotland, and Scandinavia. Observers in the northern tier of the United States reported aurora on the northern horizon through parts of the night. The 5-region solar disk was simultaneously producing C-class flares, the background noise of an active solar disk, while the effects of the cannibal CME played out at Earth. Now, the current state of each active region, because the number 5 active regions simultaneously, is the number that characterizes July 30th as a genuinely unusual day in the declining phase of solar cycle 25. AR 4494, Beta Delta. This region remained the most active on the disk. It maintained a weak delta magnetic configuration, which can produce significant flares. However, its spot area continued to decay overall. It produced both M-class flares during the period. AR 4493, Beta Gamma. This region showed significant decay in its trailing spots as it approached the western horizon. Its magnetic complexity reduced from Beta Gamma to Beta. It produced several low C-class flares. AR 4495, Beta. This region displayed decent growth during the period. It also contributed multiple low-level C-class flares. This region is one to watch for further development. AR 4496, Beta. This region initially showed slight growth, then it began to decay about halfway through the period. It produced isolated low C-class flaring. AR 4497, Beta. This region received its number during the period. 5 numbered active regions on the Earth-facing disk, each one carrying its own story and its own risk profile. AR 4494 is the veteran of this burst. The region that produced the M3.2 on July 26th, that has been classified Beta Delta for days, that launched the CMEs responsible for the cannibal CME arrival. Its spot area is decaying overall, which is the expected trajectory for an active region in the second or third week of its transit across the disk. But decay does not mean safe. A decaying Beta Delta region still maintains a weak delta configuration as long as opposite polarity umbra share penumbra in the same sunspot group. The delta classification can persist even as the total spot area shrinks. The strongest flares from some active regions historically occurred during the decay phase, when magnetic flux from the satellite spots of the group reconnects with the leading polarity in a geometrically favorable configuration. AR 4494's decay trajectory makes the next 2 to 3 days the final window of its M-class flare potential before it rotates onto the far side. AR 4493 is past its peak. The decay from Beta Gamma to Beta represents a genuine reduction in magnetic complexity. Beta Gamma regions can produce M-class flares. Pure Beta regions typically do not produce flares above C-class under most day-to-day circumstances. AR 4493 is approaching the western limb, and its final crossing into the far side will remove it from the geoeffective zone. Its contribution to the current burst is winding down. AR 4495 is the one to watch. The Earth-Sky Summary's characterization, decent growth during the period, and one to watch for further development, the language used when a region is showing the kind of flux emergence behavior that could lead to increased complexity if it continues. Flux emergence is the process by which new magnetic field from the solar interior pushes upward through the photosphere and appears as new sunspot penumbras on the surface. New flux can either expand an existing sunspot group's area without changing its magnetic topology, or it can introduce new polarity elements that complicate the topology and raise the magnetic classification. If AR 4495's growth continues through its current position on the disk, it could develop into a more complex classification, beta-gamma, or, in a more energetic scenario, beta-gamma delta, by the time it reaches the central meridian in approximately 5 to 7 days. AR 4496 and AR 4497 are currently simpler in magnetic classification, both beta without the delta component that signals the highest flare risk. The picture this 5-region disk paints is of a sun that is not quiet by any standard measure in a phase that the cycle data says should be producing declining activity. How common are 5-region, highly complex disks in the declining phase of a solar cycle? Looking at the solar cycle records maintained by NOAA and the Royal Observatory of Belgium, the answer is not very. The typical declining phase sees a gradual reduction in the number of active regions, a simplification of their magnetic structure, and a corresponding drop in flare frequency and intensity. July 2026 is not following that script. That deviation from the expected script is what makes this period technically past its peak, involves the solar dynamo's behavior in ways that the July 19th presentation at the National Astronomy Meeting 2026 in Edinburgh put in specific and consequential context. Scientists have developed a new way to predict the strength of the sun's next activity cycle up to 7 years before it reaches its peak. The talk, a new declining phase precursor to predict the next solar maximum sunspot number, took place at NAM 2026 in Edinburgh on Monday, July 20th, 2026. A new declining phase precursor, 7 years of lead time on predicting the next solar maximum. The method described at NAM 2026 uses measurements made during the current cycle's declining phase, specifically the rate at which the sun's polar magnetic fields strengthen, to predict the amplitude of the next cycle's maximum. The physics behind this is well established in heliophysics. The polar fields that build up during the declining phase of one solar cycle serve as the seed magnetic field for the next cycle. A stronger polar field at the end of cycle 25 predicts a stronger cycle 26 maximum. A weaker polar field predicts a weaker maximum. Solar activity appears to have exited the solar max phase as of February 2026, with a strong decrease in the number of sunspots observed. The northern polar field has weakened considerably over the last months, and although there is a chance the field could recover over the next 1 to 2 years, there is an increasing chance that solar cycle 26 will be very weak. The southern polar field is not impressive either. However, a southern polar coronal hole has formed early in 2026 and appears to be growing. The northern polar field has weakened considerably. There is an increasing chance that solar cycle 26 will be very weak. This is the finding from the July 2026 declining phase analysis. The same measurement that the NAM 2026 presentation is using as a precursor for cycle 26 amplitude is already showing values that suggest the next cycle, which will peak approximately 11 years from now, around 2035, may be substantially less active than cycle 25. The mechanism is the same one that made cycle 24, which peaked in 2014, the weakest solar maximum in a century. A weak polar field at the end of cycle 23 produced a weak cycle 24. And a weak polar field at the end of cycle 24 produced a slightly stronger, but still relatively weak, cycle 25. If the polar field at the end of cycle 25 is weak, the prediction is that cycle 26 follows the same declining trajectory. For the immediate present, July and August 2026, the polar field measurement is not what matters operationally. What matters is the active regions currently on the disk, the CME sequence that has already delivered geomagnetic storm conditions, and what the remaining week of July and the first week of August will look like as the current cluster of regions evolves. The sun returned to a low flare level over the past day, producing C-class flares only. Observers logged 12 flares, Arkansas 4,494, peaking at 3:18 UTC on July 28th, C5.2, after the M3.2 that launched the Cannibal CME sequence. After the M-class flares from earlier in the month, the sun dropped to a C-class only flaring on July 28th and 29th, which, in the context of this month's activity, represents a genuine brief pause rather than a return to sustained quiet. AC 5.2 is not a trivial solar event. It is at the upper end of the common flare class, the flare class that produces minor radio blackouts on the sunlit side of Earth in some frequency ranges. But compared to the M3.2 that launched the cannibal CME, a C5.2 represents the post-eruption relaxation of the active region's magnetic field while it builds toward the next episode. The question of when and whether the next M-class or X-class event occurs from this complex of active regions is the question that NOAA's Space Weather Prediction Center is currently issuing daily probability forecasts for. Those probabilities: the percentage chance of an M-class flare in the next 24 hours, the percentage chance of an X-class flare, are driven by the current magnetic classification of the active regions on the disk and their recent flare history. With AR 4494 still at beta delta and AR 4495 showing growth, the M-class probability is not at the low levels associated with a quiet disk. It is elevated. An elevated M-class probability in the current solar wind environment, with Earth's magnetosphere still recovering from the cannibal CME, with the coronal hole high-speed stream from the central meridian still in transit, means that additional geomagnetic disturbance is possible even before a new major CME erupts. The last element of the current situation that scientists are watching specifically is the coronal hole that rotated onto the solar central meridian on July 29th. A central meridian coronal hole's high-speed stream arrives at Earth approximately 3 to 4 days after it crosses the center of the disk. From a July 29th central meridian position, the arithmetic puts the stream arrival at approximately August 1st through August 2nd. That timing places it arriving immediately after the cannibal CME's geomagnetic effects are winding down, potentially preventing the full magnetospheric recovery that would normally occur between two distinct solar disturbances. The compound effect of a cannibal CME followed by a coronal hole high-speed stream separated by only a few days is what forecasters call a prolonged disturbed period. Not a single storm's main phase in recovery, but a sustained elevated geomagnetic environment that operates for 4 to 6 days, as one disturbance gives way to another before the magnetosphere returns to baseline. For aurora watchers across the northern tier of the United States, Canada, Scotland, Scandinavia, and New Zealand in the southern hemisphere, the current extended disturbed period means that conditions favorable for mid-latitude aurora sightings are not limited to the hours immediately around the cannibal CME's main phase impact. The high-speed stream arrival on August 1st through 2nd provides a second window of elevated KP potential, typically not as sharp or as intense as a CME main phase, but sustained for longer, producing overnight KP values in the 4 to 5 range that can push the aurora oval southward during the storm's most active hours. Take a step back from the individual active regions and the specific storm parameters and look at July 2026 as a chapter in the solar cycle story. The cycle peaked in October 2024. February 2026 marked the beginning of the statistically confirmed declining phase. And then July 2026 delivered the machine gun sun, the 3 CME sequence, the synchronized dual eruptions, the cannibal CME, the 5-region active disk, and a polar field measurement that suggests the next cycle may be weaker than this one. A declining cycle that looks more like a maximum than a minimum. A sun that, by every operational metric that matters to power grid engineers and satellite operators and aurora watchers and radio operators at high latitudes, is behaving with a level of sustained activity that the long-term cycle data says it is supposed to be growing out of. What scientists are watching closely is whether July 2026's burst is a transient anomaly, a brief localized period of elevated activity within a genuinely declining phase that will resolve into quieter conditions in August, or whether it represents a secondary maximum in the overall cycle, the kind of double-peaked activity that cycle 23 and cycle 24 each displayed in different forms, where the cycle produces a second period of elevated activity several months after the smoothed maximum has been established. The answer will come from observing how quickly the active regions currently on the disk decay and rotate off, how many new complex regions emerge from the solar interior to replace them, and whether the polar field measurements that are the leading indicator for cycle amplitude start recovering or continue to weaken. If new complex regions keep emerging in August and the polar fields remain weak, the picture that emerges is of a cycle that is declining from its official maximum, but is doing so more slowly and more actively than the standard post-maximum decline trajectory. 1 week of a 5-region active disk does not answer that question conclusively, but it contributes to the dataset that will eventually answer it. Every NOAA active region report, every DSCOVR real-time measurement, every Earth-Sky Daily Sun update, every Space Weather Live solar region summary. All of it is building the picture of what this particular solar cycle is doing in its decline, and how that decline will compare to the historical record of cycles that preceded it. The Sun is not entering a new maximum, but it is in a highly active phase within its decline, and the 5 regions on the disk today, AR 4494 at Beta Delta, Arkansas 4493 decaying, Arkansas 4495 growing, Arkansas 4496, and AR 4497 present and numbered, are the current physical expression of a star that is still producing significant complexity in its magnetic field even as the long-term trend curves downward. Scientists are watching closely because the synchronized dual eruptions of July 27th, the Cannibal Sea of July 29th, and the 5-region disk of July 30th are not noise. They are the signal of a declining solar cycle that is not going quietly. That signal is being read in real time by a global network of observatories, satellites, and forecast centers, all working to understand not just what the sun is doing now, but what it might do next. The stakes are high because the sun's activity has direct consequences for technology, infrastructure, and even human safety. Power grids, satellites, aviation, and communication systems all depend on a stable space environment, and when the sun becomes active, that stability can be disrupted. The more we understand about the sun's behavior, the better we can prepare for and mitigate those disruptions. That preparation starts with forecasting. NOAA's Space Weather Prediction Center issues daily forecasts of solar activity, including the probability of M-class and X-class flares, the likelihood of CMEs, and the expected geomagnetic conditions at Earth. These forecasts are based on a combination of observations, models, and expert judgment, and they are updated regularly as new data becomes available. The goal is to provide accurate, timely information to those who need it, from power grid operators to satellite controllers to aurora chasers. The current forecast calls for continued activity from the active regions on the disk, with a chance of more M-class flares and possibly another CME. The Cannibal CMEs effects are winding down, but the coronal whole high-speed stream is on its way, and that will bring another period of elevated geomagnetic activity. The exact timing and intensity of that activity are still uncertain, but the general outline is clear. The sun is active, and it is going to stay active for at least the next few days. For those who are affected by space weather, the key is to stay informed and to be prepared. Power grid operators are monitoring geomagnetic indices and are ready to take preventive measures if needed. Satellite controllers are watching for signs of increased drag and radiation, and they are prepared to adjust orbits or put spacecraft into safe mode if necessary. Aviation authorities are tracking solar radiation levels and are ready to reroute flights if conditions warrant. And aurora chasers are keeping an eye on the forecasts, hoping for another good display. The science behind all of this is complex, but the message is simple. The sun is active, and we need to pay attention. The declining phase of a solar cycle is not supposed to be this active, but here we are. The sun is doing what it wants, and we are doing our best to understand it and to prepare for it. The more we learn, the better we can protect ourselves and our technology from the sun's whims. That learning is ongoing. Every new observation, every new model, every new forecast adds to our understanding of the sun and its effects on Earth. The synchronized eruptions of July 27th, the Cannibal CME of July 29th, the 5-region disk of July 30th. All of these are data points in a larger puzzle, pieces of a story that is still being written. The sun is not done surprising us, and we are not done learning from it. The next chapter in this story will be written in the coming days and weeks, as the active regions on the disk evolve, as new regions emerge, and as the polar fields continue to change. Will July 2026 turn out to be a transient burst, or will it mark the beginning of a secondary maximum? Will the polar fields recover, or will they continue to weaken, pointing to a weak cycle 26? The answers to these questions are not yet known, but they will be revealed in time, as the sun continues to do what it has always done: change, evolve, and surprise us. For now, the sun is active, and we are watching. The forecasts are being updated, the data is being collected, and the models are being refined. The next flare, the next CME, the next geomagnetic storm, all of these are possibilities, and we are ready for them. The sun is not going quietly, and neither are we. That vigilance is not just about protecting technology. It is also about understanding our place in the solar system. The sun is the star that makes life on Earth possible, and its activity is a reminder of the dynamic, interconnected nature of the solar system. When the sun flares, when it ejects plasma, when it sends storms our way, it is not acting with malice or intent. It is simply being a star, governed by the laws of physics that dictate how magnetic fields and plasma behave. Our task is not to control the sun, but to understand it, to anticipate its effects, and to build systems that can withstand its variability. The current period of activity is a case study in that ongoing effort. An active region produces a series of flares, one of which is accompanied by a coronal mass ejection. Forecasters model its trajectory, estimate its arrival time, and assess its potential impact. Infrastructure operators monitor the situation, ready to respond if conditions worsen. The public is informed, not alarmed, and encouraged to enjoy the aurora if they are in the right place at the right time. All of this happens with a level of coordination and professionalism that would have been unimaginable a few decades ago. But the work is not done. The sun will continue to cycle through periods of high and low activity, and we will continue to depend on technologies that are vulnerable to space weather. The challenge is to stay ahead of that curve, to improve our forecasting, to harden our systems, and to educate the public about the risks and the realities. The goal is not to eliminate risk entirely, which is impossible, but to reduce it to a level that is manageable, and to ensure that when a large event does occur, we are as prepared as we can be. The active regions that produced the July 2026 burst will eventually rotate out of Earth's strike zone, and their flaring will subside. The cannibal CME will pass, and the geomagnetic storm will fade. The aurora will retreat to higher latitudes, and life will return to normal. But the sun will produce another active region, another flare, another storm. That is the nature of the star we live with. And as long as we remain a technological civilization, we will need to keep watching, keep learning, and keep preparing. For now, the forecast remains active, with a chance of more flares and CMEs and a high-speed stream on the way. The sun is not going quietly, and neither are we. We are watching, we are learning, and we are preparing. The next chapter in this story is yet to be written, but we are ready for it. The sun is active, and we are paying attention. Subscribe and turn on notifications for continuing space weather updates. NOAA revises its forecasts every 3 hours, while DSCOVR and other satellites measure the incoming solar wind in real time. When the next significant development from this 5-region disk breaks, this channel will have it before it reaches anywhere else. The sun is not done surprising us, and we are not done learning from it. The story of our relationship with our star is far from over. It is being written every day, in the data from our satellites, in the decisions of our operators, and in the awe of those who watch the sky. We will be watching too.